Hello everyone, I am Divya, working for the Department of Computer Science and Engineering. After routing table poisoning, the next kind of threat that the network is going to face is packet mistreatment attack. Okay. This attack is directly concerned with the data packet that is traversing inside a network. Packet mistreatment can happen during any data transmission. A hacker can hack and get an access to the packet, and he can mistreat that packet either with the information inside the packet or about the routing information, so that can be routed to a different destination which is of not in concern with that particular data packet. Okay. This is about packet mistreatment attack, and it is very difficult to detect packet mistreatment attack. As we all know, if there is any data packet drop, usually in normal condition also several times data packet drops do happen. So, it is very difficult to detect whether it is a packet mistreatment or actual network strategy to handle the transmission of packets inside the network in a proper way. Okay. Packet mistreatment attack will result in congestion inside the network, and denial of service can also happen as a result of packet mistreatment, and sometimes replication of packet, okay, and interruption, modification, several things can happen in case of packet mistreatment attack. There are two kinds of packet mistreatment attack similar to our previous attack, that is router attack, that is line attack and router attack. Okay. In case of line attack, if a packet is traveling along the line between the routers, if hacker gets an access or hold on the packet at that point in time, then that results in interruption and modification of the data that is there in the packet, and then the replication of data, which might result in lower throughput, okay, and then loss of data, many more things. Okay. If router packets get attacked at the router itself, then the router information for that particular packet might get misinterpreted, or that is going to be mistreated, which results in congestion in the network or denial of service in case of network. Okay. So, this is about packet mistreatment attack. Now, we will see few examples of packet mistreatment attack, how it can happen. Okay. So, to begin with, it is interruption. We have 5 attacks listed here, that is interruption, and then modification, replication, and then ping, message broadcasting, ping of death. And the last one is malicious misrouting of packets. These are the 5 examples of packet mistreatment attacks. What happens in case of interruption? When a packet is being transferred over a network, if an attacker gets an access to the packet, he is going to interrupt the packet, and he makes that packet to drop. He avoids that packet to get delivered to the destination. Thereby, here it results in loss of packet along with lower throughput of the network. Here it is very difficult to find whether it is an interruption caused due to the packet mistreatment or is it a natural network strategy, because as I already told you, during the normal circumstances also sometimes the network decides to drop few packets in order to avoid congestion, right. We have seen while studying about routers, if there is any congestion happening, then few packets are might get dropped or might get marked and kept aside. So, this particular thing, interruption, is very hard to detect. Okay. So, this results in loss of packet as well as the lower throughput of network. Okay. The next one is modification. Once an attacker gets hold on the content of the packet, he can mistreat the content. He can modify the content itself. So, a wrong information might get delivered to the destination, or he can modify the routing information and make that particular packet to route to the different destination which is of not concern as far as that particular packet is concerned. Okay. That is about modification. Then comes the replication. In this case, a packet which is get attacked by an attacker is going to be replicated to many numbers. Before that, this modification attack can be handled with the help of digital signature. Okay. By having a digital signature in our data packet, we can handle this kind of attack over our data packets. The next one is replication. Here a packet which got attacked by an attacker is going to be replicated for many times. So, many number of same duplicate copies of same packet is going to be pumped into the network, which will result in congestion, okay, due to overload of duty. So, this can be avoided. Receiving same copy of data packet can be avoided with the help of sequence numbering. We have seen about sequence numbering previously when we were studying about routing algorithms, right. So, with the help of sequence numbering, giving sequence number to each packet that is going to be originated from a source to a particular destination, we can avoid this. So, when a receiver receives a message data packet, it first checks the sequence number. If it already has a packet with that particular sequence number, it just discards instead of keeping on receiving the same data packet and reading the entire information and then making a decision whether it is the same packet or not. So, with the help of sequence numbering, we can avoid replication, the effects, after effects of replication that is happening with respect to packet mistreatment. The next attack is ping of death. Here an attacker will send a ping message. Okay, he will send a ping message to a network which is of a long length, which is of a huge length or huge size. So, when we have a message which is of huge length, we cannot transmit it as it is. It is going to be fragmented and it is transmitted to the destination. On the receiver end, when a receiver receives this message, it starts reassembling those messages since it is too lengthier. So, since the message is too lengthier, while reassembling, the system might get crash. Okay? This might result in system crash. That is about ping of death. So, when a receiver receives the ping message and tries to reassemble the fragmented message that is sent by an attacker to the network, it results in the death or the system crash. Okay. The last example that we are going to consider here is malicious misrouting of packets. Here the attacker is directly going to attack on router, okay, not on the data packet. Here it is directly going to attack the router itself, and the routing information is being mistreated by an attacker, and the packets are routed to a wrong destination in this case. So, these are the 5 examples which we are considering here. So, this is about packet mistreatment. As a result of packet mistreatment, what all things can happen? Either packet can get lost, so we are going to lose the data here, loss of information, or information might get corrupted, or information might get replicated with a, in case of replication, or it might result in the system crash itself, or it might get routed to a wrong destination. So, these are the effects of packet mistreatment attack. So, we have studied 3 types of attacks: DNS attack and then routing table poisoning. Now, it is packet mistreatment attack. Moving on to the next type of attack, that is denial of service attack. So, the next kind of attack is denial of service attack. The previous 3 attacks or threats that we have discussed are going to result in the loss of data majorly. Okay, we are going to lose the data, or we are when it is traversed to a different destination, or the packet itself is being dropped in such case. But here in case of denial of service attack, more than the loss of data, the end user are made to avoid from getting the actual service which the that particular server was providing. For example, an end user might want to get an access to some server which is there, which is present here. Okay, our end user want to get a service from this server, but a server is made so busy in such a way that it will not be able to provide a service to our end user. Okay. So, the victim here in case of denial of service is the end user. The server is overwhelmed by some false or some unwanted things. It is overwhelmed by some unwanted things such that it will be busy in doing these things and it will fail to provide service to the actual end user. Okay? That is what denial of service attack is all about. Here we are not going to have data loss. Data loss will not come into picture here. Okay? So, here mainly the service itself is avoided for an end user. So, we will study more about this. As I already told you, denial of service mainly affects the destination rather than the data that is transmitting over a network. Okay. Here in case of denial of service, it majorly affects some server which is going to provide service to its end users. For example, our email server, okay, or DNS. As we all know, DNS is going to play a crucial role as far as network is concerned, right? It helps us in mapping IP address with domain names, and then it helps us in name aliasing, email aliasing, all those things. So, what it's going to do, it's going to attack that server itself and makes that server go down for few hours, which results in lack of service for their end users. Okay. So, denial of service attack can be done in 2 ways. One is single source and another is multiple source. Okay, or distributed. So, denial of service attack can be implemented or can be done in 2 ways. One is with the help of single source and another one is with the help of distributed mechanism. In case of single source, plenty of messages will be generated from a single source and it is pushed to a network in such a way that routing of that packet inside that network will enter into a loop, because tracing back the source address is very tough, almost impossible. Okay. In this case, since it cannot trace back the source, it is very tough to detect whether it is a denial of service attack or it is really causing congestion due to a normal scenario. Okay. So, it is programmed in such a way that source address is not traceable and huge number of packets are pushed inside the network. So, it keeps on revolving around the network, thereby that particular server or that particular portion of network goes down and the service will not be provided to the actual end user there. Okay. And then in case of distributed system, several hosts are used instead of one host. Here in case of distributed, several hosts are used. All these hosts are going to generate number of data packets to the server like flooding. So, that results in flood and that particular portion of network or server goes down, thereby avoiding that server to provide actual service to the actual end user. This flooding can happen either with UDP, we call that as UDP flood, or TCP Synchronous Flight, which we call as or ICMP flood. Okay. UDP flood can attack two systems on the transmission line. So, making either system to go down and thereby it will not work. In case of TCP Synchronous Flight, how exactly TCP works? Usually in case of TCP, one SYN message will be sent from one host to another host, right. Here this is receiver, this is sender. How TCP will work? Sender will send a request to a receiver, receiver will send a acknowledgement to the packet which it has received, right, in a timeline. How it happens in case of TCP Synchronous Flight? This server, in case of distributed denial of service attack, number of hosts are going to send huge amount of SYN messages to the receiver. Okay. So, several SYN message will hit receiver here, the target system, okay, the server where we want to attack. The server will not be able to send ACK message back to the host in order to complete its work, because the source address will not be clearly available for receiver from a source. So, thereby this results in TCP synchronous flood. Okay. This is how denial of service attack affects the end user rather than the data that is being transferred in the network. Okay. So, so far we have studied about 4 kinds of threats with respect to network security. First one is DNS attack, and then second one is routing table poisoning, third one is about packet mistreatment, and the fourth one is denial of service attack. So, this clears our very first topic, that is overview of network security. Moving on to the second topic, that is overview of security methods. So far we have studied about different threats, different kinds of threats that a network can come across, right. When we are aware of different threats that we are having in case of network, we need to find out the techniques with which we can handle these kind of threats, right. So, the security methods can be classified into 2 categories here. One is cryptographic method and another is authentication methods. So, we have two categories of security methods that are applicable with respect to computer networks. The first category of method is cryptographic method and second one is authentication method. What do we mean by cryptography or cryptographic method? Cryptography is a technique which has got huge history. Okay? For long ago, cryptography was used to maintain the secrecy of information with respect to our military and many more things where the data is very confidential. Nowadays, our network engineers are also very much interested in cryptography. So, what do we mean by cryptography? Cryptography is a technique in which a message which is of very confidential, when we want to transfer that message from one end to another end, that message is going to be scrambled in such a way that if any intruder or an attacker gets an access to that particular message, he will not be able to understand what exactly it is. Okay? So, on receiving that information on the receiver end, the receiver is going to decrypt it. So, inside the cryptography, we will learn two things. One is encryption and another is decryption. When a confidential information need to be transmitted from a sender to a receiver, at the sender end, the message is encrypted with the help of a secret key. Here we are going to make use of secret key, okay, that is going to be encrypted and it is transmitted over a network. On the receiver end, when that particular message is received by a receiver, that receiver is going to decrypt that scrambled message to get the actual message. So, here both the parties, that is receiver as well as the sender, they both share the same secret key. Okay, they make use of secret key. The commonly used operation in order to perform encryption and decryption is exclusive OR. So, during the process of encryption, if our message is M, if M is a message, okay, and K is a secret key here. So, if a message M is going to be transferred from a sender to receiver, so with the help of exclusive OR operation, it is encrypted and it is sent to a receiver. On the receiver end, once again, how it is decrypted? It is the secret key is again used with exclusive OR operation to decrypt the actual message. So, this is encryption, this becomes the decryption process. The entire process is called as cryptographic method. Okay? In a network, two levels of cryptographic method is involved. One is end-to-end encryption, okay. Another one is link encryption. Here, if we have a network, if I have a server here, server A, and one more server here, which is server B, between server A and server B, I will have a encryption and decryption mechanism here with a secret key, or you can call this as cryptographic method. Okay. So, this constitutes end-to-end encryption. So, server A and server B, these two are servers. Okay. These two servers communicate with each other without any data loss in between or without any threats in between through cryptographic method of security. Okay. At both the end, we have cryptographic block. In between, we might be having several routers like this, right. Each router will get connected through various links. So, between each of these routers there will be a security block. Okay. These blocks are called as link encryption. So, between each router, when a data packet exits from a router, it is going to be encrypted and then transmitted, and on the other side of the link, when the data packet is going to arrive on the other side of the link, here that particular data packet is decrypted and sent to the router. Similarly, if that packet need to traverse from this point to this point, again that packet is going to be encrypted at this end and it is going to be decrypted at this end. So, that at each link the protection is provided with the help of link encryption. At each server we are going to provide the protection with the help of end-to-end encryption. So, at different levels we are going to provide security with the help of encryption and decryption. After this, there are two kinds of cryptographic methods or encryption methods. What are they? One is secret key encryption, and another is public key encryption. We have seen that we are providing cryptographic, with the help of cryptographic method, we are providing security to the network in different levels, at different levels, right. Link with the help of link encryption and end-to-end encryption. So, when we have seen that encryption is being provided at all levels, so through what methodology we are going to provide that? We have two methodology or two categories of encryption algorithms. One is secret key encryption and another is public key encryption. What do we mean by secret key encryption? In case of secret key encryption, both sender and receiver, here both sender as well as receiver both share same key. Okay? They both share same secret key in order to encode and decode or encrypt and decrypt the message which is being transmitted over the network. Okay? Other than sender and receiver, no other routers or hosts or servers will be made available about this secret key. In case of public key, it makes use of public key in order to encrypt and decrypt. It will be available publicly. Compared to these two, secret key encryption and public key encryption is most powerful. Okay? This provides most powerful security system to our data which is transmitting over network. But there is one disadvantage, that is the speed with which it performs. It takes too much of time as it needs lot of computations. Computational complexity is more in case of public key encryption. So, because of high computational complexity, the speed with which public key encryption algorithm works is lower compared to secret key encryption. So, what we will do, when a session is established between a sender and a receiver, initially a public key encryption algorithm is used to share a session key. Okay? In order to share a session key between a receiver and a sender, a public key encryption algorithm is used. Once it is done and a session is established between a sender and a receiver, secret key encryption methodology is used in order to provide security further. Okay? This is how we are going to make use of cryptographic methods in order to provide security as far as our computer networks is concerned. Okay? Moving on to the next thing, that is authentication method. Why do we need one more method to provide security as we are already using the encryption mechanism? With the help of cryptographic methods or encryption mechanism, we are assuring confidentiality to the data, isn't it? We are ensuring the confidentiality. so that the data is not going to be mistreated by any hacker or intruder. But what about the authenticity? What about the authenticity? Means when a packet is sent from a sender, it has to reach the exact router. The destination should be the proper destination, proper receiver, right? How to assure the authenticity? So that can be done with authentication method. Here authentication method can be performed with two methods, that is, one is with authentication with message digest and one more is with the help of digital signature. So we are going to study these two things under authentication method. So we are going to study about secret key encryption algorithm, public key encryption algorithm, and then message authentication with respect to message digest as well as digital signature, all these things in our next classes. Okay. For today this is about the security methods. So we have studied about overview of network, the elements of network security, and then the threats that the network is facing, the kinds of network threats that we are having in nowadays, and then we have studied about the security methods to encounter those network threats. Okay. Next we are going to study these things in depth in our next classes. Thank you.